In 1976, you could eat breakfast in London and land in New York before lunch. That was real. It happened every single day for 27 years. Today, that same journey takes 7 hours. This is not a temporary setback. This is a permanent step backward. The fastest passenger plane ever built flew its last flight in 2003. We never replaced it. Commercial aviation went from breaking the sound barrier to simply accepting it. So here is the question worth answering. Why did the world choose to fly slower? To understand how we lost supersonic flight, go back to October 1947. Test pilot Chuck Yeager climbed into the Bell X-1 rocket plane and broke the sound barrier for the first time in history. The message to every government watching was unmistakable. If military aircraft could do this, passenger aircraft should follow. By the late 1950s, the jet age was in full swing. Space exploration dominated global headlines. President Kennedy had pledged to land a man on the moon before the decade ended. 3 nations launched supersonic passenger programs simultaneously. America began the Boeing Supersonic Transport Program. The Soviet Union developed the Tupolev Tu-144, and Britain and France did something extraordinary. Traditional rivals, they became partners. On November 29, 1962, Britain and France signed a formal treaty to build a supersonic jet together. Neither country could fund it alone. Together, they would share the cost. Hundreds of millions of pounds and francs were committed. Thousands of engineers across 2 nations worked toward one goal: getting passengers across the Atlantic faster than the speed of sound. America dropped out in 1971. The Boeing program never carried a single passenger. The Soviet Tu-144 flew first, but barely survived. 2 major crashes ended its life after fewer than 100 commercial flights, most carrying mail. But on March 2, 1969, Concorde took off from Toulouse. It worked. On January 21, 1976, it entered commercial service. For 27 years, it crossed the Atlantic in 3.5 hours. Then, in 2003, it stopped. Not because it failed, because the math stopped working. Start with what Concorde actually was. Its fuselage was 8 feet 7 inches wide inside. A Boeing 747 stretches over 20 feet across. Concorde carried 100 passengers. A 747 carried 400. Every design decision pointed towards speed. Everything else was a compromise. The wing shape was called an ogive delta, triangular with a curved leading edge. At low speeds, this shape generated the extra lift needed to stay airborne. At high speeds, it minimized drag and absorbed heat. At Mach 2, twice the speed of sound, air friction heats the nose to over 260 degrees Fahrenheit. The aluminum fuselage expands 6 to 10 inches on every single flight. Pilots reported feeling heat directly through the cockpit windows. To manage the shift from takeoff to supersonic cruise, engineers designed a fuel transfer system. Fuel moved forward during takeoff and shifted backward as the aircraft crossed Mach 1. This continuously redistributed weight to maintain the correct center of gravity, because without that balance, the aircraft became unstable at speed. To reach Mach 2, the engines required afterburners. These inject additional fuel into the exhaust to generate enough thrust to cross the sound barrier. They burned fuel at an extraordinary rate, and crossing that barrier produced a sonic boom, a physical pressure wave strong enough to shatter windows on the ground below. That sonic boom delivered the first fatal wound to the economics. In 1964, the United States Air Force conducted 6 months of supersonic flight tests over Oklahoma City. Residents filed over 15,000 noise complaints. Hundreds of windows cracked or shattered. By 1973, the United States formally banned supersonic flight over land. Other nations followed quickly. Concorde's routes shrank to the ocean. The trans-Pacific corridors connecting Tokyo and Los Angeles were now permanently off-limits. Concorde was left with only the North Atlantic. That geographic constraint was not just inconvenient, it was structurally crippling. Most people blame the crash for killing Concorde. The reality is more precise. On July 25, 2000, Air France Flight 4580 was accelerating down the runway at Paris-Charles de Gaulle Airport. A titanium strip fallen from another aircraft lay on the tarmac. A tire struck it and exploded. A rubber fragment hit the underside of the wing at over 200 miles per hour. The fuel tank ruptured. Fuel ignited. 113 people died. The entire fleet was grounded that day. Engineers redesigned the fuel tanks with Kevlar lining and installed burst-resistant tires. After 15 months of testing, Concorde returned to service in November 2001. It was flying again. It was fixed, but the seats were empty. September 11th had occurred weeks earlier. The airline industry was in crisis. Luxury travel had collapsed. Concorde flew on for 2 more years. Then, on April 10, 2003, Air France and British Airways announced retirement. That announcement revealed what the crash had obscured. Concorde was not killed by an accident. It was killed by the numbers it had been carrying since 1976. Concorde was subsidized by 2 governments from its very first commercial flight. Only 2 airlines ever operated it, British Airways and Air France. No other carrier placed a single order in 27 years. With only 20 aircraft in existence, every spare part required custom manufacturing. By 2003, the cockpits were analog in a fully digital world. The fleet still required a flight engineer, a role modern jets had eliminated decades earlier. Then Airbus announced it would no longer supply parts. Upgrading the fleet was financially impossible. The comparison to the 747 made the problem unavoidable. A Boeing 747 carried 400 passengers at $500 a ticket. Concorde carried 100 passengers at $1,200. On overlapping routes, the 747 generated more than twice the revenue. Boeing built over 1,500 747s. Only 20 Concordes were ever made. The 747's parts were mass-produced and cheap. Concordes were hand-built and costly. The 747 did not win because it was superior technology. It won because it was superior business. Someone thinks they can change the outcome. Boom Supersonic is developing an aircraft called the Overture. The stated goal is New York to London in 3.5 hours. United Airlines and American Airlines have already placed orders. The ambition is real. But the challenges that grounded Concorde have not disappeared. Supersonic flight over land remains banned across most of the world. Fuel consumption at Mach speeds still far exceeds subsonic aircraft on the same routes. The scale problem persists. Producing enough aircraft to bring parts costs down requires demand that does not yet exist. Boom is working with NASA, the National Aeronautics and Space Administration, on quiet supersonic technology. The goal is to reduce boom intensity enough to allow overland routes to reopen. If that research succeeds, Pacific corridors become accessible. That single change could transform the economics entirely. But the structural challenge remains unchanged. Concorde never turned a consistent profit, even with direct government backing. Any successor must operate as a viable private business from the very first commercial flight. Pricing, route selection, and fuel costs must all align simultaneously. None of those are small problems. The technology is closer than it has ever been. Whether the economics can follow is the question Concorde never answered. We built the fastest passenger plane in history. We flew it for 27 years. Then we ran the numbers and walked away. The question was never whether faster flight was physically possible. The question was whether anyone could make it pay. If this changed how you think about aviation, subscribe. New episodes every week.